Dear students, welcome you all. In the last class, we have discussed in detail about what is testing of textiles, what is the need for doing testing for textile materials, that may be fibers, that may be yarns, and that may be fabrics, and that may be garments, and what are the different objectives of doing this testing. All these things we have discussed in detail in the last class. Okay, so today's class we are going to start with this, how to determine the sample size and how to select the samples for testing. These two things are very important thing. Okay, so about these two topics we are going to discuss in today's class. Okay, so if you look at the contents for today's presentation, one is we are going to discuss in detail about how to determine the sample size for testing. Sample size for testing. And the second one is how to select the samples for testing. That may be fibers, that may be yarns, fabrics, or garments. Okay. Now, so let us go into the first topic, that is determination of sample size for testing. So, by looking at this statement, what you can understand, determination of sample size for testing. That means you have to do the testing and what is the sample size you are taking. What is the sample size you are taking? Say for example, if there is 1000 kgs of yarn you have produced, 1000 kgs of yarn you have produced. Okay, now you have to test the yarn quality. Say for example, you have to test the yarn strength which is there in 1000 kgs. Now, are you going to test all the 1000 kgs of yarn? Do you think it is possible? Or even though if it is possible, would you prefer to do the testing of all 1000 kgs of yarn? Say yes or no. Obviously it is no. Why? Because if you do all the 1000 kgs of yarn testing, now what will happen? Do you find any product there? So everything is going to be waste. Why? Because the strength checking is, it is a destructive test. So once if you do strength test where you cannot reuse that yarn, understand, you cannot reuse that yarn, then how you will determine the sample size? So in that 1000 kgs of yarn available, are you going to test 1 kg or 2 kgs or 3 kgs or 4 kgs? This is called the sample size. This is called the sample size. So out of the population, 1000 kgs is the population. From the 1000 kgs population, the 1 kg or 2 kgs or 3 kgs, which is nothing but the sample. Which is nothing but the sample. So our today's topic is how to determine the sample size for the testing. Okay. Now, if you look at this, when the subject of sampling is discussed, the question will arise, how many samples would we test? This is the first thing. We have a population and we need to test it. So in the beginning itself, we will get a question, how many samples should we test? Should we test all the samples, all the population? Should we test half of the population? Should we test quarter of the population? How many samples? This is the first question which is arrived in our mind when it comes to this sampling part. Okay. So this question asked in this manner gives no indication as to what set of conditions the sample has to satisfy. The sample has to satisfy. Understand? The quality control engineer, even if you take the quality control engineer perspective, so he can be little or no information when it comes to establishing sample size. Unless he knows what is required of the sampling plan. If he doesn't know about the sampling plan, even the quality control engineer, he may also not having any idea about this sample size. Then what he might be know, he must know something of the process involved and the characteristics being measured and what degree of protection is demanded of the sample selected. Understand? He must know something of the process involved and the characteristics being measured, that is process involved in testing, what kind of characteristics we are expecting to measure, and what degree of protection is demanded of the sample selected. So by knowing these things, where the quality control engineer, he might have assumed so the sample size. And for these questions to be sensible, it should have been, the question should have been like this, where I am just reading the question, you carefully understand this. How many samples should we test? How many samples should we test in order that our test results, how many samples should we test in order that our test results will be within a given percentage of process average at a certain percent of time. So if you test how many, this many number of samples, so the results will be within a given percentage of average at certain probability of certain error, So where the question should be like this. Understand? Again I am repeating, try to understand it clearly. So how many samples should we test in order that the test results will be within this given percentage of process average, and with this particular error. Understand? Where the question should come like this. Now we will see some practical examples. So how to ask this? For example, it might be, how many spinning bobbins? This example is related to spinning. How many spinning bobbins should we take at one time? Should we test at one time, so that the skein test results, skein is nothing but loose yarns or loose threads, which we also call it as lead. The lead test results will be within 0.25 pounds of the 2 process average with a probability of 95% of error. Understand? Where we can ask the question like this. So then he will proceed with the rest of the things. Understand? Again I am just reading this example. So try to understand carefully. How many spinning bobbins? So if you test this many number of spinning bobbins, say for example 100 spinning bobbins, and whatever the test results you are getting, that should be within this 0.25 plus or minus pounds of 2 process average. Understand? So the question now set forth. If you look at the question, it says what is the definite condition. Here what is the condition? The test results will be within plus or minus 0.25 pounds of the process average. This is the definite condition, and which the sampling program and sample size must meet. So this is how the questions should be there, in the process of getting or determining the sample size. There should be a definite condition, which should, all the results should meet the definite conditions. Okay. Now, whatever these calculations we are doing for the appropriate sample size for averages is a fairly simple and easy calculations. So this many number of samples we are measuring, we are testing, so that the test results will meet this process average. Understand? Which is very fair and simple and easy calculations. And moreover, it is an accurate method of determining the number of tests necessary to satisfy a given set of circumstances, a given set of conditions. It is an accurate method, okay, which satisfies the given set of conditions. Okay. For example, here we are going to see some numerical example so that you can easily understand how to determine the sample based on the required conditions or given circumstances or given conditions. Okay. For example, if you take a yarn number which has an average skein strength of, that is average strength of yarn strength of 90 pounds, that is the average strength of skein is 90 pounds and a standard deviation of 7 pounds. Standard deviation in the sense what? That is nothing but SD, which is of 7 pounds. Okay, this is the information, this is the criteria. The average of skein strength is 90 pounds with a standard deviation of 7 pounds from the mean values. Now the question is how many tests must be made so that, listen carefully, how many tests must be made so that the average of test results will be within 1.5% of population average about 95% of time. So if you do this many number of tests, so that whatever the test results you are getting, that should be within the 1.5% of population average with 95% of probability. So this is what the question is. Now if you try to pick out whatever the information which is given in the problem, so where mean is given, we are representing mean with x bar, that is 90 pounds, which is given in the I think we have seen in the last slide, and standard deviation, which we are denoting with sigma, which is nothing but 7 pound is given, and what are the other information is given, percentage of error is given, sampling error, that is 1.5% is given. So it is given in the problem. And finally, the probability also given, that is the probability that the average of test results, falls within the given limits, that is 95%. So all these are the information given in the problem. Here with this information we need to find out, or we need to determine, so what could be the sample size, so that the test results will meet this population average, that is 90 pounds with a sampling error of 1.5%, with a sampling error of 1.5% and a probability of 95%. Okay, now we will try to find it out or figure it out what could be the sample sizes. Okay, so in order to determine this, where we are using a formula, so which is nothing but, you can see here clearly, so n is equal to t square into v square divided by e square. Here t is nothing but, it is a ratio where we can get these t values from this table. So in the problem, the probability p percentage is given as 95%. At 95% probability, the t value is 1.96. So from the table we can take this value directly, and v stands for coefficient of variation. How to find out this v value? In order to find out this v value, in the problem we are given with standard deviation and then mean. Is it right? So standard deviation by mean into 100 will give us coefficient of variation. Again I am repeating, this small n is nothing but the sample size. The small n is equal to t square into v square divided by e square. So here t is nothing but the table values. So at 95% probability, you can see the table which I have given in the slide. So at 95% probability, the table value of t is 1.96. So we are taking this, and v stands for coefficient of variation. So we have a formula to find out this coefficient of variation, that is standard deviation divided by mean multiplied by 100. So in the problem, the standard deviation is given as 7 and mean as 90. So 7 divided by 90 multiplied by 100. So divided by this capital E stands for percent of error. That means from the average, so 1.5 percentage error will be there. That is sampling error. That is 1.5. So divided by 1.5 whole square, and this will give us the sample size of 103. So what do you mean by this number 103? This means that if a total of 103 tests are made, that means if you carry out 103 tests, okay, the average of the results will be within an error of 1.5 percentage of population average, approximately at 95 percentage of time. This is the meaning of it. Okay, so again I am just repeating it. If you just go back to the previous slide, where we have to determine the sample size, where what are the given conditions are, where the mean should be of 90 pounds with a standard deviation of 7 pounds, and sampling error should be within 1.5 percentage at a probability of 95 percentage. These are the given set conditions. So if we want to meet these conditions, how many number of tests to be carried out? And we have a formula, n is equal to t square into v square divided by e square. Here small n stands for sample size, small t is nothing but the table value t, which is a ratio, where we can get the t value from this table, and capital V stands for coefficient of variation, and capital E stands for percent error, which is given in the problem. So for at 95% probability, the t value given is 1.96. We can take the value directly from the table, and V stands for coefficient of variation. I told you already. So coefficient of variation, there is a formula, standard deviation by mean into 100. The standard deviation given is 7, mean is 90, multiplied by 100. So divided by capital E is nothing but percent error, which is 1.5. So if you simplify this, where you are getting the value of 103. Now finally you arrived at the sample size need to be 103. So what do you mean by this number 103? That means if you test 103 samples, or if you test the scheme for 103 tests are made, the average of these will be within 1.5 percentage of population average, approximately 95 percentage of time. Understand? If you do this many number of tests, then only it will meet the conditions of your average 60 and your average 90 with a standard deviation of 7 at your error of 1.5 at 95% probability. Understand? So this is how we need to calculate the sample size. We need to determine the sample size for testing. Okay, and not only we can find out the sample size, and we can also find out the different other aspects also from the formula. Okay, so other than determining the number of samples to be carried out, suppose that it is impossible for a laboratory to perform 103 tests. Think that, okay, 103 tests we need to do, in the sense it is not a small number. Okay, and it can test only 65 samples, where the laboratory can test only 65 samples. That means the n value is given. In that case, so what is the probability? That the average of test results will be within 1.5 percentage of population average. So the same values we can take it, the same values, whatever the problem which we did in the last slide, the same parameters. So there we have find out the n value where the probability is also given. But here the n value which is given is only 65 samples, where we need to find out this probability, that is p value. That is probability that the average of test results will be within 1.5 percentage of population average. That is, the error is 1.5 percentage. So we can use the same formula, n is equal to t square into v square by e square. So we will substitute all the values. So except this t value. So why? Because if you know the probability from the table you can substitute the t value. But we don't know the probability p value. So obviously you don't know the t value. So you are just taking out the t separately and you are getting the t value of 1.55. So what do you, from this t value, again you can go to the table and you can refer this t value, what is the probability percentages. Now if you look at this, it is found that at a t value of 1.55 is equivalent to approximately a probability of 86 percentage. 86 percentage. That means with this set of circumstances, it can be said that the average of 65 tests will be within 1.5 percentage of population average, approximately at what probability? At 86 percentage of probability. Understand? So if you are given with all the conditions where you know how to find out the sample size. Understand? So this is all about how to determine the sample size for testing. Okay, I'll try to brief out what we have discussed till now. So we have discussed about how to determine the sample size for the testing. So for example, if you have 1000 kgs of yam, so you can't test all the 1000 kgs. So where you need to select certain sample. So before that, you need to have some kind of a set of conditions. That means what could be if you test this many samples, okay, where the average test result should be like this. The standard deviation should be like this, and sampling with this much percentage of sampling error at this probability levels. So by getting all these details like the average, standard deviation, percent error and probability, where you can easily find out the sample size from the formula n is equal to t square into v square by e square, capital E square. Here t value we can get it from the table based on the probability percentage, and v value, which is nothing but coefficient of variation, we can get it from population average and the average and standard deviation, and capital E is nothing but the error percentage, that is allowable error. So by having all these data, where we can easily find out this sample size. Okay, so this is about the sample size determination. Okay, till now we have discussed. Okay, next, the next topic which we are going to discuss in today's class is selection of samples for testing. That means from the name itself you can easily understand how to select. So in the last in the previous slides we have seen how to determine the size, that means the number. Now here we are not at all talking about the number. We are talking about how we are picking, how we are selecting. If you are having 1000 kgs of yarn, how you are selecting? Are you selecting the samples only from particular place, or only from the place where all the cones are looking good? are only from the place where the starting cones are placed, are only from the place where the top side cones are placed. So that is the topic which we are going to discuss. So it is not that we should take the samples only at the good looking cones. Okay, there is a procedure for selection of samples. Okay, so why I am telling or why we are discussing this topic is, so if you don't select your samples, so as per the required things, if you don't follow any kind of method in selecting your samples, so what will happen is, where whatever the samples you have tested, which will not represent your population, which will not represent your population. Okay, so here in this image you can see, the first one you can see, where from the entire population, that means 1000 kgs of yarn is your population. From the population, you are selecting your samples. Okay, so here in this image you can see. So in the population, so many persons are there, where if you want to select few among them as a sample, if you want to know certain aspects, say for example about one product quality, you are selecting the samples not from a particular place, you are selecting randomly and you are having your sample. Now if you test this sample, so which is the true representative of this entire population, true representative of entire population. Why? Because you cannot test all the population. No? You cannot test all the population. Why? Because it is a time consuming process and lot of cost also involved in it. Okay. Now, so before going in detail into this, how to select the samples for testing, where we will see what is a population and what is a sample and what is sampling and all these things. Basic things and all we will discuss. What is population? Population is nothing but a total system. A total system. So which we are going to study. For example, where if you have to test 1000 garments, 1000 garments is your population. Okay. So if you want to know the quality of your 1000 garments, where you are going to pick few samples, few garments out of 1000. Say for example, 10 garments or 20 garments or 30 garments. Okay, that is nothing but the sample. So here, population is nothing but the 1000 garments. The 20 or 30 you are taking from the population is called as a sample. So a sample is relatively a small fraction which is selected from the population. The 20 garments we are selecting from the 1000 garments. So the quality of these 20 garments will decide the acceptance or rejection of the 1000 garments. Okay. Now, what is sampling? What is sampling? Or why we need this sampling? Suppose if you take the example which I told you now, 1000 garments are there. If you want to know the quality of the 1000 garments, is it possible? Is it possible for you to test all the 1000 garments and give the certificate about the product quality? No, it is highly impossible. Why? Because if you just try to check the quality of each and every garment, it is a time consuming process and lot of cost also which is involved. Okay, that's why we are going for the sampling process. Means the total raw material brought or the total end production is not 100% tested due to cost effectiveness and time constraints. Because of these reasons, where we are going for the sampling process. And the sampling also, the destructive type of testing. So after doing the sampling, where we are going for testing. Testing, we have non-destructive type and destructive type. Say for example, if you take strength measurement, which is a destructive test, Likewise, the destructive type of testing, will also increase the wastage. Once the test is done, you can't use the product for the next purpose. Okay, which will ultimately increase the cost of testing, resulting in overall profit being decreases when if you go for testing 100% of your products. Okay, therefore the sampling techniques are employed and representative samples of the whole material are tested. Only the representatives. From the 1000 pieces, we have selected the 20 as a representative. So only the 20 representative only we are testing. And based on the quality of the 20, we are deciding the quality of the 1000 garments. So this process we call it as sampling process. Understand? For example, for the testing of cotton fiber, if you have 250 kgs bale is there, only we are taking 20 milligrams weight of sample. Now see, this 20 milligram sample of cotton which will represent the 250 kgs bale. See how small we are taking. But the selection of the 20 milligrams weight of sample is very important. If the 250 kgs of bale is there in the sense, you should not pick the 20 milligrams of sample at one place. If you do like that, and whatever the test results are there, that is not the true representative of the entire 250 kgs of bale. You should pick out randomly from all the places of, that is the different places of the bale. Then that will give you the right quality about the entire population. Okay. Now, so that is what again is the sample, whatever we are taking from the bale, that should be taken in such a way that each group's fiber length has an equal opportunity being selected to be included in the sample. That is different parts of the bale where we should pick out the fibers, and that should be considered as a representative of the entire bulk. Okay, and why we are doing like this? The main objective is to get an unbiased test sample. Biased and unbiased. Suppose if I take the fiber from the bale where at one particular place, or where the place I found it is very good, or if I take only the fibers from top of the bale, or if I take only the fibers from bottom of the bale, that kind of sampling is called as biased sampling. Unbiased in the sense where I don't know exactly about the place. So at that point of time, I just pick the fibers randomly from different parts of the bale. So which is a true representative of the whole population. Understand? So each and every part of the possible length group is represented in the sample. Understand? Now we will see this need for sampling in textile testing. So in our textile testing, that may be of fibers, that may be of yarns, that may be of fabrics, and that may be of garments. What is the need for sampling? Again, if you see, the testing is a destructive in nature. Once the testing is done, where the sample is going to be waste. Understand, sample is going to be waste. So it is not desirable to test all the material. That's why we are going for sampling process. And if you look at the textile production, which is always huge and bulk, okay, it is impossible to test all the final output from a production process. That's why we are doing this sampling process. So that's the only a true representative. Here you have to understand the representative sample of the material are tested will save the time and cost. Okay. Now, whatever the sampling methods we are following or we are adopting, that depends on certain factors, certain parameters. One is the form of material. So what is a form of material, whether it is fibers, whether it is yarn, whether it is fabric, or whether it is garment. And second one is amount of material available. Amount of material available. Whether the availability of the material is more or the availability of material is less. If material availability is more, obviously we will take more samples. If the availability is less, we will do the testing with less amount of sample. And nature of test. That means whether the test is destructive or non-destructive. Suppose if you are measuring the fiber length and fiber fineness and fiber length and fiber fineness. So these are non-destructive tests. That means after the testing we can use that material. Suppose if you are measuring the fiber strength, if you are measuring the fiber strength, or if you are measuring the yarn strength, obviously the test is said to be a destructive test. So that means after strength measurement where you cannot use that material for the process, that is called as destructive test. So depending upon whether it is destructive or non-destructive, the sampling method also varies. And type of testing instrument. What type of instrument we are using for testing? Are we using a manual instrument or are we using any advanced instrument? So why? Because there is a difference in finding out the fiber length using comb sorter and by using this AFIS. And the quantity of material as well as the preparation of sample, everything is different. And the next one is information required. What kind of information we are expecting from the samples? Are we expecting only few informations? Are we expecting much information from the sample? So depending upon that also the sampling method varies. And finally, the degree of accuracy required. What degree of accuracy we are expecting? If your accuracy level is more, if you are expecting the accuracy levels are very high, obviously you have to do you have to select more number of samples and you have to do more number of tests. Okay, these are all the different sampling methods which are dependent on, one is form of material available, whether it is fiber, yarn, garment or fabric, and amount of material available, that is for doing sampling or for doing testing, and nature of test, whether it is destructive test or non-destructive test, and type of testing instrument that is available, information we are expecting from the testing process, and finally accuracy levels which are required. So all these things are dependent on, the sampling methods are dependent on all these parameters. Okay, so next we will see about the types of sample. Types of sample. So mainly there are three types of samples. One is random sample. One is random sample. Okay, random sample in the sense what? Where from the population, now you can see in this image also, this is the best example. From the population where we are taking the sample randomly. So from this image you can easily see that 1, 2, 3 rows are there, where from this total of 12 population we have to select 4 samples. Now you see how the samples are selected here. So from the 1 to 4 they have selected 1 sample, and 5 to 8 they have selected 1 sample, and 9 to 12 they have selected 1 sample. So the selection of sample also it is random. From the first row they have selected the second one, from the second row they have selected the first one, and from the third row they have selected the second one. So the selection of sample should be random, so that whatever the sample we are getting, that is the true representative of the population. True representative of the population. Understand? This is called as random sample. And next one is numerical sample. Okay, when we are calling it as a numerical sample in the sense, a sample in which the proportion by number of, say, long, medium and short fibers would be same in the sample as in the population. That means in the population and sample both are having same number of long, medium and short fibers. That kind of sampling we call it as numerical sample. And finally we have biased sample. So I told you already bias sample. Again, if you look at the image, this is not the image of bias sample, but I'll explain you what is bias sample from this image. Now you can see, if you take the same one, 3 rows are there. This is total 12 number is a population. If I take the first number from the population, 5th number and 9th number. So from each and every row I am taking the first sample. Then that would be bias sample. Or you can see the population is represented with 3 different colors: blue, red and then green. Suppose if I take only the red color samples, 2, 6, 11, it is going to be a bias sample. Or 3, 5, 9, it is going to be a bias sample. So if you just relate this with the practical applications, like if you have 1000 kgs of yarn which is placed like this, now if you take the samples from the bottom only, or from the top portion only, or the portion of cones where it is looking good, that kind of sampling is called as biased sampling. And if you do the bias sampling, it won't truly represent your population. If you do the sampling like that, and whatever the test results you are getting, that is not true. That is not the true representative of the entire population. So this is called as biased sampling, and these are the different types of sampling. Okay, so this is all about the today's class. Okay, so in this session we have discussed in detail about what the determination of sample size for testing and how to select the samples for testing. In the determination of sample size, we have discussed how to determine the sample size for testing based on the formula n is equal to t square into v square by e square. And in the selection of samples, we have seen in detail about what is a population and what is a sample and what is sampling and why we need sampling in the textile testing, why we need to do the sampling in textile testing, and what are the merits of doing this sampling process, and what are the different parameters where this sampling is dependent, and finally different types of sampling like random sample, numerical sample and then bias sample. Okay, so I hope you understand this class. Okay, so we will meet again in the next class and we will discuss about some other aspects which is there in this first unit. For example, sampling errors and then point and interval estimations of mean and variance. Okay, thank you.